Hey everyone, thank you guys so much for joining our session. What I wanted to do to start is just give you an overview of what we plan to cover today. So we'll introduce ourselves so you can understand who we are, what we do, and then we'll talk through 5 main topics. First is going to be what's the current status of logging within the Hadoop ecosystem today, and what are some of the things that we're doing within Ambari to make it easier for operators to find key messages, exceptions, and logs across very large clusters. Then we're going to talk about metrics. So we'll be talking about the Ambari metric system and some upcoming work that we're doing within AMS to be able to detect anomalies, multiple different types of anomalies, to help our operators not just stare at a wall of graphs, but really be able to be notified when specific issues happen so they can pinpoint the specific anomaly and the specific metric for a specific component during troubleshooting. And then we're going to talk about upgrades. So we're going to focus on specifically a capability that we built within Ambari for patch upgrades. This would be basically patching individual services within our entire stack and how that actually works. And then we'll talk about some improvements we're making to the core of Ambari, specifically around management packs, and being able to allow operators to create multiple instances of services, like multiple Hive instances, or even multiple instances of components, like 3 or 4 different Hive server 2s running on the same box. And then we'll talk about some of the work we're doing in SmartSense that works with Ambari to be able to pump recommendations into Ambari so that our operators get more information about kind of best practices and how to make sure that the configuration keeps pace with how they're actually using the cluster. So these are the 5 things that we kind of plan on presenting today. Each section will be based on a different Ambari committers and community work that we're presenting on their behalf. So we'll start with introductions. My name is Paul Cotting. I've been at Hortonworks for about 6 years, and I work on the Ambari team.
Hey. Hey everyone, I'm Oliver Szabó. I'm a member of Ambari Budapest team. I mainly working and focusing on log search and Solar and not really the Ambari core itself. And that's it.
Thanks. So first we're going to start with logging. So this work has been done by Oliver as well as Toby and many other people on the Ambari team. But what we want to do is really just kind of for each of these sections focus on what is the specific issue that we're trying to solve. So within Ambari, we've really tried to focus recently on making log rotation easier to configure within our components. So being able to configure things like the rolling file appender, daily rolling file appender within Ambari itself, instead of having to dig through individual log4j.xml template files and doing that yourself. But we wanted to be able to go a step further. For a lot of our customers that run multi-100 node instances of Hadoop, we wanted to make it really simple for our users to be able to find key exceptions, messages within this kind of haystack of logs that our Hadoop components produce. We have a ton of components, and each one of them produce at least 2 logs. And so we want to make it really easy to pinpoint specific issues as they occur. So the challenge is really how do we build a scalable solution that can work for 30+ projects within our specific HTTP and HDF ecosystems. And we want to make it super, super easy and something that's fun for us to use as operators. So Oliver's going to kind of take you through the technical approach.
Okay, so log search. So because of that, we are built log search. As its name says, that's a log aggregation analytics tool for Ambari managed services. But it's more easily to define based on the requirements. So what we want is just simply storing logs, surging in them, and it should be centralized. So for now, we included 4 basic components: Solar, Zookeeper, Log Feeder, and Log Search. And I will talk a bit about these components and what are the connections between those. So first of all, we have Solar, that is a search engine, basically. We choose that over Elasticsearch. So the reason for that was mainly because that is Apache. So not because it's Apache licensed, it's because in Apache. And what it does basically for us, it will store logs, and it's capable of doing full text search. So because when you are sending lots of data to Solar, it has really nice tokenizers. So it can create different fields based on how you tokenize your data. So mostly that work on with tokenized based on white spaces, or it can work somewhere else, of course. And we are using that in Solar Cloud mode. So for that, we are needing Zookeeper. And what Zookeeper does, it basically do the coordination for the Solar nodes and also contain those informations, where are those nodes are located, how are those shards named, or of course it contains also security informations as well, like is it Kerberized, or we are using basic authentications and so on. And also we have a log feeder. So basically that is our log shipper component. These are agent components, so that runs on every host. And it has some input descriptors. And in the input descriptors, you can find which logs you want to tail and where are those located and what kind of patterns that the log have. So we need to tokenize the log lines first. So because there can be some other informations there, what we can use. So for example, we need the dates, like timestamps, or we need the log level itself, because it's mostly troubleshooting tools. So most of the times we are not really curious about the info level logs or the debug level. We want to know when errors or warnings happened. So that runs on every host, and it sends the data to Solar. It's a really pluggable component, so we can send data to somewhere else as well. So we can send it to HDFS or Kafka, but mainly we are using with Solar because of the full text search capabilities. And also it uses Zookeeper as well, because it needs to know where the Solar nodes are located. And of course we have log search server. Basically that's a portal around the log data. So you have a nice UI for your architecture, and it acts as a proxy for Solar, but not a real proxy, because it transforms the request and the response to our needs. So it's not just proxying stuff, and with that we are not really dependent on Solar. So Solar here can be pluggable. Maybe someone has another preference to use Elasticsearch anyway. So we can put log search server on top of that. But for Ambari, it's not really the case. So that is how we are using that right now. And of course, here's the user who's interacting. And of course, it's not really, so we have another not really component. I would say it's just an interface. So I mentioned before, log feeder has input descriptors to know what kind of inputs needs to be monitored and what are the patterns and so on. So we created a config API, which is basically handle that information and storing these patterns in Zookeeper. But it's a config API, so you can use something else as well, like Consul or etcd or anything else what you want. And log search server itself can access that config API, so it can change the patterns when it's needed. Sometimes it's needed because there are like date patterns, which depends on what kind of machines you started and where, which zones, for example. So dates can be different, so you need to change the patterns. And with that, log feeders don't need to be restarted, because they are subscribed to Zookeeper, or I mean the config API, but we are using with Zookeeper. And so what I talked about is, so that's what I talked about. We are using log feeder as our log shipper. So we had to write this, because first we tried Logstash, but because we choose Solar, we had some requirements with, especially with security, and we had some performance issues as well. So we write our own one. But of course, you can change that and use your preferred one like Fluentd or anything else. And for log collection, we are using Solar. And that's what we have today. And
Yeah, go ahead. So does this mean that log feeder make an exact copy of the log file in Solar and index it? So Solar indexing, right?
Yeah, so in this
Yeah.
case, the question is,
The log file.
so in this case, is the log file replicated within Solar? Not necessarily. So as Oliver was explaining, the log feeder actually is configurable. So you can basically say, I only really want to index like warning or above or critical or above, right? Yeah.
The local file still exists.
The local file still
Yeah.
exists.
Plus the second copy in the
Yeah, but I wouldn't consider it a second copy. We're not taking everything.
indexed copy.
Yeah, an index subset of the log is in Solar. The original file is still on disk. So if you SSH that box, you can still see the log file, but you'll be able to search an index copy of whatever log levels.
UI has some reference back to the actual file.
Yeah, the question is, does UI have an access, to the individual file itself? So you can, once you've seen a match in a specific, maybe get 15 log items, you can click preview and you can see the specific log entry in context of the rest of the logs. Mhm.
okay, so our plan is for the future for Ambari 3.0 is to do something with the logs, because it's nice we are storing that and we can search in that, but we should do something with those data because those are valuable. So what we are planning to do is through the log search server, you can access Solar or anything else. So you have your data there and you can write policies what you want to monitor to see, like for example, how many fatal errors was there on your cluster. So you will know what will happen on your cluster. Like every day you got like some notifications or some emails or with nice PDF files that what happened. So that's our goal here. And I will just show a really quick demo about the config API. So what I talked about. So here we can see the log search UI. It changed a bit. So we had log search before, so it's in tech preview, but we changed it to use Hortonworks style. And what I want to show is, so for log feeder we have these kind of shipper configurations, and for that we also build a UI to check is my pattern matching and so on, because sometimes it's really problematic if those are not working well. Oh, sorry, Zookeeper. So that was right. Yeah, so it could be parsed, but if I just remove the date pattern, for example, it should not be able to parse. And here you can see what we will send to Solar, what kind of fields. Yeah, so it says I cannot parse that, yeah.
Yeah, and one thing to add to this too is when we've been using this with customers in their production environments, non-production environments, one of the things that commonly comes up is they like to be able to use this for our products, but they also want to be able to index things like varlog secure, varlog messages. And so that's something that's been added to the product as well in the latest tech previews. You can have operating system logs side by side with our Hadoop logs.
Yeah. Okay, I got some pictures if it would not work.
Yeah, then from a timeline perspective, just to see if you like what you've seen, you want to give it a shot, we have the log search in tech preview with Ambari 2.6. It was introduced a while ago in Ambari. The plan for GA of log search will be 3.0. But we encourage you guys, please use it, give us some feedback. You can reach me at paul@hortonworks.com, and I'd be happy to answer your questions.
Yeah, so what is missing mainly is a better documentation for it, and we want to make everything really pluggable.
Sweet.
Yeah.
The next thing we want to present is some improvements we're making to our metric subsystem. So this work was done by Sid and Aravind on our team, and it really kind of came from the background of we have a lot of graphs. We've got a ton of charts within Grafana and within Ambari itself. And what our operators really want is, instead of being, having to stare at a wall of graphs, be able to instead be notified when we identify anomalies, or when something like a region server crashes or a data node crashes, be able to look at what are the anomalies that we had detected before that specific crash, so they can get to a root cause faster. So our goal really is to build a system that can detect multiple different types of anomalies in our time series data, because every one of our individual components reports back a massive amount of time series data, including the operating systems that those specific components run on. So we have a lot of data at our fingertips. We just need to be smarter about it so we can save our operators time.
Okay, so basically what we did is to add anomaly detection system to our metrics. So the idea is the same what I mentioned with log search. We have the data and we want, or we should do something with it, not just storing them. So for that we have three different techniques how to get anomalies. And the first one is the point-in-time anomaly. That is the most simple one. So you can imagine that like a one-time peak. So for example, you have like a small index installer and someone hits the optimize button, and that will use like lots of CPU. So in the CPU graph, you will see a big change, and maybe that will cause a different service to fail for some reason. So in that case, it's hard to find that was the root cause itself, and this kind of anomaly detection technique can find these issues. We have the trend anomaly, so that almost similar, just the difference is it's a bit larger time frame. So for example, if you see like for weeks your memory usage of your service is just growing slowly, so you can see a trend is changing. So that can mean you have some issues on your cluster, or even if you are using a service frequently, and for, I don't know, for Tuesday, for some reason, that was not really used. So that also can mean some problems on your system. And we have the correlation anomaly. That's a bit harder one. So there you can detect if you have any dependencies between different metrics. It requires some more iteration because sometimes there is no dependency at all. So it can be a bit misleading, but if you're doing that frequently, or your system is doing that frequently, you can find the root cause of your problems on your cluster. And we have these three different subsystems, and we are running these techniques on like every metrics which are related. We are using different techniques and algorithms for all of these anomaly detection techniques, and because sometimes we got some result, but maybe that's not correct, so we try another one, and the result can be like closer for true. And how we will do that in Ambari? So in Ambari we have alerts as well, like something goes down or using too much memory or something like that. And based on that, these techniques will be triggered to check what could happen on your cluster before it happened. Okay, maybe that's not the best example because here HBase server crashed, but maybe we can check an event like it uses too much memory, or you have your disk size is too low, for example. And here the architecture of it. So what we are doing, we have our own Ambari metric system. So basically we are storing data in HBase. I highly recommend it to use HBase in distributed mode. This distributed is a bit misleading as well. That means you're storing your data on HDFS, and you have a HBase on top of it. And with Kafka, we are streaming our metrics, and we have some Spark jobs which are running, and we have a anomaly detection store, and it stores the results, and so it's hopefully that job won't run too often, but if it is, it will update the results, and on Ambari UI, you will see that what really happens on your cluster. So that's pretty useful, I guess.
Yeah, and then from a timeline perspective, we've had AMS in the platform for a long time. We've recently GA'd multiple metric collector support within AMS. So if you have a cluster that's greater than 150, 250 nodes, it can be a great benefit to have 2 or more metrics collectors. Artem, yeah, question. Yeah, so the question was the Kafka mentioned in the previous architecture. Will there be the ability to have an external Kafka that's referenced, like in a broker that you already have? And that, yes, we'll make that parameterized. You can choose which specific Kafka broker to use. Yep. But for those of you that have used AMS, if you've had performance issues, multiple metrics collectors will be a big help, especially in big clusters, and that is GA. The anomaly detection work, we've done a ton of POCs on this specific work. We've had really good results. The plan is to have that GA in our next major Ambari 3.0 release. The next thing we want to cover is upgrades. Upgrades for any Hadoop operator are just great events, super fun. Not really. We've done a lot of work in Ambari to make technically the upgrade process a lot smoother, but you still have a huge organizational challenge when it comes to upgrades. Most of our customers' clusters, it might take them 3 months to get the upgrade plan, get all the lower level testing done. It might take you 4 hours to complete the upgrade, but a lot of the organizational process around that can be really challenging. So what we tried to do is make it easier for us to apply specific patches. So if you work with Hortonworks support, you have an issue, you get a hotfix from us. Let's say you have an issue with Spark or Hive or a data node with an HDFS. With this work, we can now give you a service-specific hotfix, and you can use rolling or express upgrade to actually apply that hotfix. So instead of having to upgrade the entire cluster, we can pinpoint specific services and just move them forward. Hopefully, cause a lot less pain when it comes to upgrades and make it a non-event. So we'll kind of go through exactly how that's being done, and Oliver's going to explain it.
Okay, so the main problem was with upgrades, mainly with the hotfixes, especially. We had like a big stack with lots of services, and some of the cases people were happy with their cluster, but they hit some issues with Hive or HDFS, and they just want to fix those issues. But for that, they needed to upgrade the whole stack, and people was not really happy about it because the other services performed well. And then after the upgrade, maybe they will find newer issues in different components. So the plan was really, so we cannot handle different services as stacks itself, but we could map every service to a specific repository. So we use that approach to implement patch upgrades. So here, okay, so it's really simple. That means if you have like a small fix that you won't require to upgrade the whole stack. You will just require to upgrade what you want or what you need to, basically. That can mean you need just upgrade Zookeeper, or maybe Zookeeper and HDFS and nothing else. It's mainly working for small hotfixes, because one of the main, before I will go there, so about the technical approach. So it will work with version definition files. That means we will have a descriptor which contains the URLs and everything what you need to upgrade just Storm or anything else. And the main problem with that was some of the cases, if there is a major change in Hadoop or in one component, that means you will end up with the same situation. So you will need to upgrade like 6 or 7 components anyway. And
Yeah, and so
that's
just to
a
clarify
lot.
too, where possible, with different components, we can just upgrade the individual services. But for other things, maybe like Tez or for Hive, we might have to bundle things together. So like Hive, Tez, and MapReduce might have to go forward at the same time. So wherever possible, we try to just upgrade the individual service, but Ambari is aware enough to understand what all needs to be upgraded at the same time if multiple services need to go.
Okay, so here there's some slides about how it will work. So you will have that version definition files, what you can download from somewhere if we have a patch, and you can upload it, and you will see it will contain only yarn.
Yeah, go for it.
So remember a few years ago, and as far as I remember, up to recent time, there was a clearly declared that we not ship hotfixes. We ship only the full, verified, tested, and complete version. So this completely diminished the previous application, right?
Yeah, the question was around just the approach that we would take. So typically when we ship fixes from Hortonworks, we would certify the stack altogether and then ship the whole stack, right?
How many permutations you can certify?
Yeah, but in this case, for what I want to be kind of clear on is with these patches, we build and test the whole stack, and then we just give you a descriptor that says Ambari, just move that forward. And so we'll test the permutation for each hotfix. And it's a heavy process, but that's what our release engineering and support does. Yeah.
Okay, so here you can see that you need to upload that version definition file, then you will see this on the UI, and you will just only upgrade yarn, and hopefully it will be green here.
Yeah, the thing to note too is we support both rolling and express upgrades. So just like any other version, when you put the VDF in, it'll just show the subset instead of moving the whole stack forward. In this case, we're just moving yarn forward. The other thing to note is you'll see two current stacks. So in this case, you'll see the base stack that you initially installed, as well as the individual service that we move forward. We also built the ability in for you to be able to revert those specific patches. So for whatever reason, we give you a fix for Hive, it has unintended consequences. We have a full wizard to roll it back, much as you would downgrade prior to finalizing an upgrade. From a timeline perspective, this is something that's already out. So this is GA in Ambari 2.6.1. So this is something that has been out for a while. There are some preconditions. In order to use patch upgrade, you have to have Ambari 2.6.1, and you need to be using HTTP 2.6.4 or above in order for patch upgrade to function. Yeah, Artem. So the question was, if you do a patch upgrade, like in this case, you export a blueprint of this specific cluster and then install it on a new one, will that function? And yeah, as long as you have the valid repos behind these specific versions, that would function. Mm-hmm. Correct, yeah. Mm-hmm. So the next thing I want to cover is some core work that Jayush and his team has been working on. So one of the things that, we've had challenges with when in Ambari is when we started the project, we had like 8 components in one product. But now from a Hortonworks perspective, we have 3 different products, over 30 different components. And so it's been a challenge for us to have customers mix and match these specific components like HTTP plus HDF plus IBM, Big SQL, et cetera, et cetera. And so we have some structural changes that we're making to Ambari to be able to make it much easier for us as a multi-product company to ship products and customers to be able to independently upgrade and control the life cycle of each of these different products on the same cluster.
Okay, so these management packs is basically about Ambari should be pluggable, so you should be able to plug in services, which is supported right now, but it's a bit static in Ambari 2X. So that means you can add your own services, which is fine, and it can be a part of an Ambari installation. But you have difficulties with, for example, with upgrades, because the Ambari code itself contains what should happen during the upgrade, and if you have your own one, it cannot be a part of it. So you need to do some tricks to make that work, or remove the service, or re-add, or do your own backups for your service, which is really problematic. And of course, some words about the new MPEGs. So what we did here basically is we externalized stacks. So that solved that problem what patch upgrade has. So we have lots of, or not lots, so we can have multiple stacks which can exist on the same cluster. And basically that's what MPEG is. So what we are doing, we have some like some dependent core services like Zookeeper, HDFS, Yarn. Those can be one MPEG, and we have like data flow MPEGs like Kafka itself or Spark. And the idea is we have like flexible relations. So for example, you have a security MPEG where you have Atlas, and that requires Kafka to be installed on your cluster, but maybe you already have a Kafka, and that requires a different version. So you can also handle different versions of Kafka as well. So this system will make it possible for you to do that. And here you can see some technical details. So we will call, so the stack basically will be called like MPEGs, and we will have the modules. The module will be like a small part of MPEG, like a service, like Zookeeper client and so on. And right now we are installing these with RPMs, and also you will have some dependencies between MPEGs, as I mentioned. Maybe one service will require another one, and those. So you need to know which are those. So the UI or the Ambari server code will handle that for you, and the interface will be much more dynamic, I would say, because right now you have the service definitions, and you need to put your own code there and restart Ambari, and that will read about the service definitions. And right now, then you can just register it if you want. So you don't need to restart it, for example. And here is an example of the architecture. So you can see different service groups. So we have the core one with Zookeeper, HDFS, Yarn, and so on. We have like a stream service group, and we have one for HBase, and those will exist on the same cluster. And as you see here, there are different Zookeepers there. Those can be with different versions. So all these groups can have their own dedicated Zookeeper.
Yeah, and the goal with this architecture really is to be able to give customers a lot of the things that they're asking for. So I want to be able to get the newest version of Kafka, but I want to upgrade the entire cluster, so we can just move that management pack forward. Or if you have a heavy Storm or Spark use case or Solar use case, and you don't want to use the Zookeeper instance that's built into and used by the rest of the cluster, you can provision your own dedicated Zookeeper quorum for use by Kafka, for example. So it allows us to have multiple instances of a specific component on a host and multiple versions of those services within the cluster as well. So this is work that we're making changes to in the core of Ambari, and something we have planned to go GA in Ambari 3.0. This is something that'll help a lot of our customers that have management packs for their own custom services, our partners as well, and it'll help us be able to ship software to our customers faster. The next thing I want to cover really quick is some work that we've been doing on the SmartSense team. And so what I want to kind of go through is, what are some of the issues that our customers have been telling us about when it comes to configuration. Part of the challenge we have with Ambari is we have a stack advisor. That stack advisor gives recommendations on configuration whenever you add a service or add a host or make a configuration change. But those recommendations are usually frozen in time. So if you're using Ambari 2.2.2 or 2.4, your configuration recommendations are like 2 years old at this point. So the challenge we had is how can we get ahead of a lot of the configuration related issues our customers have? How can we be watching the cluster, be able to push down the current best practices for configuring HDFS or Yarn outside of a Ambari release cycle and an Ambari adoption cycle? So we had kind of 4 main challenges to figure out when we went through this. Number one is, how do we securely collect configuration metrics and logs for the entire cluster? B, how do we actually anonymize, encrypt, and get that data to us so we can analyze it? Also, how can we make recommendations based off all that data? And then finally, the last mile, how do we get those recommendations to operators like you in a way that's really easy to apply, so that's not just useless information that you have and you don't actually act on? So with that, we created SmartSense, and I can kind of walk through the architecture and how we hit each of those challenges. So our first challenge was collection. So on a really large cluster, how do we make sure we can grab configs, metrics, and logs? We created an agent that's deployed onto each node in the cluster. That agent is aware of all of our specific components, where the configuration files exist, where the logs exist, as well as what are the individual metrics within AMS that need to be captured for us to be able to know how that specific component is being used. When those specific agents are woken up and asked to capture, they'll collect configs, metrics, and logs. They'll anonymize that data and encrypt it on that box using a configurable rule set. So you can say, these are the specific properties I never want you to see. Redact this data from all the logs. If you find a user ID that looks like this, or a credit card or SSN, make sure those are redacted before the data even leaves the machine. We then pack that information into an encrypted bundle. But the next challenge is, how do we actually get that to Hortonworks? So 70% of our customers' clusters they don't have outbound internet access. So there's no way for them just to call out to the internet and get that data to us. So we had to be able to create a gateway. In this case, we created a SmartSense gateway that you can deploy into like a DMZ, and you can have multiple internal clusters talk to that gateway to get data to our environment. And once it gets there, we have to actually make recommendations. So we store that time series data, we store the configuration and logs, and then we basically ETL that into an in-memory graph database. We have a rules-based rules engine on top of that has hundreds of different rules that we've created to look for common configuration issues and specific configuration tuning parameters, and then we make those recommendations. The challenge we had is, when we started SmartSense, our only vector to get those recommendations to our operators was through our support portal. So we could make these recommendations, and our customers were like, this is great, but the challenge we had is they had a hard time getting the recommendations into Ambari. So people would type the specific things wrong. They couldn't export these recommendations and get them to their ops team for any of the sysctl OS tuning items that we had. So we had to come up with a better way. So recently what we did is we added capabilities to our SmartSense view within Ambari. So the recommendations actually just flow right back into Ambari. And this gives you the ability to basically look at all the different recs that we have. We have things for like operating system for the major components of our specific stack. And we also have ratings. So anytime you apply a recommendation, you can choose from 1 or 5 elephants and tell us how that specific recommendation worked for you. And then we give you the ratings so you can see the population, how many people applied it, how do they feel about it. So you can also export the recommendations to Excel. So a lot of these like OS-related recommendations, most likely you as an operator might not have root access to that box to be able to make a change to sysctl parameters or time zone configuration, so you can get that to your Unix team to do. But for those things that we do have access to change, like Hive or Yarn or TES-related tuning, you can do that directly from here. So click on the recommendation. In this case, we have a Hive recommendation that is setting a lot of different memory parameters. So instead of having to retype these in, all you have to do is click on the apply button, and then we'll burn that as a new configuration version for those components, restart, and you're good to go. So that capability has been in the product for a while. The latest set of recommendations in that Ambari, this Ambari SmartSense view is available on Ambari 2.6.1. It's available today. So in summary, we've gone through a number of things today. Hopefully you've learned a little bit more about what we're doing to help operators every day be able to search logs, access logs, and things of that nature. Anomaly detection is something that we've been working on for a while. It'll be GA at the end of this year, so hopefully it'll help you find those issues instead of having to look at graphs all day long. Patch upgrade, something that you can use today to just move individual services forward to avoid a full stack upgrade. And then management packs, so things like, I need 2 different zookeepers, I need 3 Hive Server 2s on this box, things that we're making changes to for the end of the year. And finally, SmartSense, so helping you have better configuration now with the click of a button. Thanks, everybody. Any questions? Yeah, Artem.
Now, when you're able to put the zookeepers on the same node, SmartSense recommendations, where they apply it.
Per instance. Yeah, so one of the details we didn't cover in detail is these service groups. So basically, for each management pack, you have multiple service groups, and those can be named and have relationships. So we'll make recommendations to the service group itself. Yeah, great question. Yeah. Yeah, the dedicated zookeepers we manage and maintained by Ambari and tracked. So you can go to Storm and say, which zookeeper instance is this? I might want to have different configuration, or I might want to restart that and not affect the one that's for HDFS, for example. Yeah. So the question was, for patch upgrade, can you apply individual service patches to just a subset of nodes? In this case, Ambari is intelligent about it. So if you have like all your Hive components on 2 of 50 machines, we're only going to roll that out to the 2 of 50. So we're not going to like roll it out to everything. We'll just only patch those specific machines that have the components that the patch applies to. Yeah, the question was, can configuration groups be used to target patches? In this case, not really. Configuration groups are only going to allow you to target individual configurations of different machines, but patches are the component and service level, so not so much. Great question. Yeah, true. Any other questions? Yeah, go for it. Okay. Yes. Yeah, great. Albert, you want to hit that? What version of Solar are we currently using?
Right now Ambari using Solar 5, but the newest one will use Solar 7.3, I guess. That's the newest.
Yeah, so with Ambari 2.7, that'll ship with HTTP 3.0. We're going to move to Solar 7. Mm-hmm. Yeah. 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 Mm-hmm. Yeah, great question. So the question was, for the search UI, is it kind of open-ended and modular like Kibana, or is it fixed? In this case, it's fixed. So we'll have a view for service logs, so you'll be able to see all the daemon logs. And we also have a audit dashboard as well, so you can see like Ranger audit, HDFS audit, Ambari audit, those types of things will be in there. But we don't have like the modular graphs and things like that like a Kibana would. Mm-hmm. Sure, yeah. Yes. Yeah, great question. So the question was, when we move, to Solar 7, what all does that affect? So log search uses the Ambari infra Solar instance. So in Ambari 2.7, we're moving that instance to Solar 7. So that means like Atlas, Ranger, log search will all consume that same Solar 7 Solar Cloud instance. HTTP search is a different product. Right now that's on Solar 6.6.2. That'll be moving to Solar 7 shortly after HTTP 3.0 is released. Yeah, great questions. Any other questions? Yes, sir. Yeah. Great question. So the first question was, all the things that we talked about, are they available with HDF? And they are, yeah. So like Ambari 2.6.1, patch upgrade, and the SmartSense recommendations are available. The caveat there is if the SmartSense recommendations would only be available if you are in an HTTP plus HDF mixed Ambari instance. If you had just straight up HDF with Ambari, that won't be possible, but that's changing very soon. The next HDF release should have SmartSense built in, and you'll be able to take advantage of those recommendations. Yeah, sorry. Mm-hmm. But the log search work is actually included in HDF. So we actually did a bunch of work for the HDF team, and Oliver did that work to include Storm worker logs, which are dynamic. So log search works with HDF. It's just SmartSense that won't until their next release. Yeah. Any other questions? Great. Thanks, everyone. Appreciate your time. Thanks, yeah.